Welcome to the Deep Dive. Imagine this: a sunny, historic coastal city, ancient and vibrant, a place you'd expect to see thriving. But along the southern shores of the Mediterranean, that image is increasingly being challenged by something, well, truly alarming.
Yeah.
Buildings are collapsing, and collapsing fast.
Yeah, and the city really at the heart of this puzzling trend, according to some fascinating recent research we're diving into today, is Alexandria, Egypt.
Alexandria, yeah.
We're talking about Egypt's second largest city, a major international port, just steeped in thousands of years of history, sitting right there, low on the coast.
And the scale of the problem here is frankly stunning. Over the last 2 decades, Alexandria has seen over 280 building collapses just along its coastlines. That's a tenfold increase compared to earlier periods.
In a volt, wow.
The paper we're looking at highlights that between just 2014 and 2020, so a really short window, 86 buildings were total losses and another 201 partially collapsed, tragically resulting in 85 deaths. It's a slow-motion crisis happening right there.
It really is.
Yeah.
And our source for this deep dive is a research paper recently published in the journal Earth's Future. It's titled Soaring Building Collapses in Southern Mediterranean Coasts: Hydroclimatic Drivers and Adaptive Landscape Mitigations. Quite a title.
It is, but it points right to the core issues. And our mission today, to unpack what this detailed research uncovers. What are the kind of hidden forces driving this devastating trend, and what potential paths forward does the paper suggest? Not just for Alexandria, right, but for other vulnerable coastal cities grappling with similar threats worldwide.
Absolutely. The research really zeroes in on this core observation. The rate of building collapses in Alexandria is accelerating dramatically, especially, as you said, in the last 20 years.
And this is happening in a city already known globally for its extreme vulnerability to sea level rise. Alexandria is home to over 5.3 million people living near the coast. It's a critical port, and much of it sits incredibly low on average, only about, 0.4 meters above sea level?
Yeah, incredibly low. And it's got this long, densely populated coastline, including many informal settlements that are, particularly at risk.
So when these collapses first started becoming more frequent, what were the initial thoughts? What did people think was causing it?
Well, the initial ideas, as the paper mentions, were often the usual suspects you find in old, dense cities. Things like lack of maintenance on aging buildings, challenges with urban management, maybe inadequate wastewater systems, and construction regulations not always being enforced properly.
Right, and those are definitely factors that can contribute to building instability in any city, aren't they? You see that everywhere.
Absolutely. But the paper points out something crucial. While these issues are present in Alexandria, they don't fully explain the specific pattern of the collapses.
The pattern.
Yeah, they aren't happening just anywhere across the city. They're heavily concentrated in certain areas, very specific geographical zones.
Okay, so the location matters.
Exactly. And that concentration is the big clue. The research followed this direct, critical link to the coastline and the environmental changes happening right there at the water's edge.
Okay, so if those common urban issues weren't the full story, where did the research look next for the real drivers? What did they find?
So the paper identifies what it calls hydroclimatic factors, basically, things driven by water and climate as the primary interconnected forces at play, and their power comes from their interaction precisely at that coastal edge.
Hydroclimatic, okay. And how does that work? What's the mechanism?
Well, the paper lays out a pretty clear step-by-step chain reaction. It starts with severe coastal erosion. The shoreline isn't just stable, it's actively retreating in many places.
The land is literally washing away.
Right, which naturally, when you combine that with rising global sea levels, pushes salt water further and further inland than it used to reach underneath the ground.
Okay, so the sea moves in, erosion happens, and saltwater pushes inland underground. What happens then?
This saltwater intrusion infiltrates the coastal aquifers, those underground layers holding fresh water, or what should be fresh water.
Right, the groundwater sources.
Exactly. And critically, that saline groundwater isn't staying put down deep. Its level is rising, pushing up towards the foundations of buildings built along the coast.
Ah, so it's reaching the base of the building.
Precisely, and this is where the real hidden damage begins. Saline, or salty groundwater, is highly corrosive. It doesn't just sit there passively. It actively degrades the stability of the ground itself, and it aggressively corrodes common foundation materials.
Like concrete And steel rebar,
Exactly, concrete and steel from below. It's eating away at the foundations.
leading ultimately to the ground becoming unstable and the building collapsing.
That's the proposed chain of events. Yeah.
And how did they actually show this connection? I mean, what kind of data did the paper use to back this up?
This is where it gets really compelling, I think. They used several methods. One was shoreline change analysis. They used satellite data and tools like the Digital Shoreline Analysis System, DSAS, to measure how the coast has moved over time.
And what did that show?
Their findings were stark. Significant erosion, averaging over 3.6 meters of retreat per year between 2001 and 2021.
Per year.
Per year, on average.
Yeah.
And that's much faster than in previous decades.
Wow, over 3.6 meters a year average loss. That's incredible movement. Did they find specific spots that were eroding even faster?
Absolutely. They pinpointed major erosion hotspots that lined up disturbingly well with where the collapses were happening. The Garb district, for instance, on the western coast, showed extreme erosion in some places. The shoreline was retreating over 31 meters a year.
31 meters a year, that's staggering.
It is. And El Montaza on the eastern side was also losing ground rapidly, around 11 meters a year, still very fast.
Okay, so the coast is eroding fastest where buildings are collapsing. Did they look at the ground underneath the buildings too? The stability?
Yes, they did.
Yeah.
This was really interesting. They used a technique involving a cosmogenic isotope called beryllium-7, or 7B.
Okay.
Think of 7B as a kind of natural tracer element that gets deposited in the topsoil. How it's distributed vertically is affected by how much the ground shifts or settles over time. So by measuring it, they could assess something called ground relaxation depth.
Ground relaxation depth sounds like a measure of instability.
Essentially, yes.
Right.
How much the ground has become less stable or settled or maybe relaxed over time.
And how did that measure up against the collapse locations? Did it match?
It correlated directly. Districts with high ground relaxation values, meaning the ground was less stable, were the same ones experiencing high numbers of building collapses. Garb, that district with the crazy 31-meter-a-year erosion.
Yeah.
It also showed the highest ground relaxation, about 7 centimeters. What's-That district followed, also with high collapses and 6 centimeters of relaxation.
So the ground is literally becoming less stable, it's relaxing or settling in the exact same places the coast is eroding fastest and buildings are falling down. That paints a very clear picture.
It really does. And then mapping the actual locations of the building collapses over the last 2 decades visually confirmed this whole pattern. The vast majority occurred in the districts closest to the coastline.
And Garb was the worst.
Shockingly so. Garb, that district with the extreme erosion and ground relaxation, accounted for approximately 96% of all the collapses between 2001 and 2021.
96% from just one district. That is an unbelievable concentration. Why is the erosion happening so severely right there? What's causing it?
The paper points to several interacting causes. A major one is the reduced sediment flow from the Nile Delta. Ever since the Aswan High Dam was built back in the 1960s, much less sand and silt naturally reaches the coast to replenish it.
Ah, the dam trapping the sediment upstream?
Exactly. And then existing coastal structures, things like dikes and wave breakers that were built to protect the coast, they can ironically trap what little sediment is moving along the coast, preventing it from reaching other areas like Garb.
Okay, so less natural replenishment and existing structures interfering. What else?
Plus, there's subsidence. The ground level itself is actually sinking in Alexandria. The paper mentions it has one of the highest rates of subsidence in Africa based on GNSS data, like GNSS measurements.
So it's a double whammy then. The sea is coming up and pushing further inland with salt water, and the land itself is sinking down.
Precisely. A really dangerous combination for building foundations.
And how does this rising, salty groundwater affect different types of buildings? Because Alexandria has old and new structures, right?
It does. You've got older buildings, maybe with load-bearing limestone walls, and newer, multi-story buildings made primarily of concrete. This rising saline water accelerates the corrosion of concrete foundations quite significantly. It also affects the older limestone, but the concrete corrosion is a major issue for newer structures.
And those older downtown areas you mentioned, Garb and Al Gamrak?
Right, in places like those, buildings often sit on these layers of alluvial deposits, basically river-deposited sediments over limestone bedrock. When seawater gets into the groundwater there, it makes those alluvial layers particularly unstable. The ground literally loses its bearing capacity.
Were there any other environmental factors the paper mentioned contributing to this?
Yeah, a couple of others. The increasing frequency and intensity of Mitigations. those sort of hurricane-like storms that can form in the Mediterranean.
Mitigations.
Their storm surges can directly damage coastal structures, weakening them. And interestingly, something happening further inland can make coastal problems worse.
How so?
Groundwater overexploitation. If people inland are pumping out too much fresh water from wells for agriculture or other uses, it can actually lower the overall groundwater pressure balance, which in turn allows seawater to intrude even further near the coast. It sort of sucks the salt water in.
Wow, it's all so interconnected. Now, what's fascinating here is this just an Alexandria story? Or does the paper suggest this kind of thing is happening or could happen elsewhere?
Oh, this is absolutely not unique to Alexandria. That's a key point the paper makes. While Alexandria is a clear and tragic case study, this combination of factors, rapid erosion, sea level rise, saltwater intrusion, rising groundwater, and the resulting structural damage is highly relevant to many other low-lying, arid, or semi-arid coastal regions facing similar hydroclimatic shifts.
Where else did the paper mention seeing similar kinds of issues or potential risks?
They brought up examples of coastal building problems that have been linked, at least in part, to groundwater rise or erosion in places like Tunisia, Italy, Nigeria, Ghana, even Brazil.
And didn't they mention the Surfside collapse in Florida?
They did, yeah. The Surfside condominium collapse, while complex, was partially linked in investigations to issues like groundwater rise potentially interacting with existing structural problems and maybe saltwater exposure over time. It highlights that even in developed countries, these subsurface environmental factors can play a role.
So, thinking about our listener,
Yeah.
why should you care about collapsing buildings in Alexandria, potentially thousands of miles away?
Well, beyond the obvious and profound human cost, the tragedy of lives lost and homes destroyed, Alexandria's situation has significant broader socioeconomic impacts. It's a major international port city, remember. It's crucial for trade routes, being so close to the Suez Canal. Disruptions there can ripple outwards economically.
That's a good point. And the scale of the risk.
The paper actually identifies over 7,000 buildings currently at risk in Alexandria due to these factors. That makes it, according to the study's assessment, the most climate-vulnerable metropolitan sector in the entire Mediterranean basin.
7,000 buildings. That's staggering. If we connect this to the bigger picture then, it really sounds like climate change isn't just some future threat of flooding anymore. It's already actively undermining our built environment today through these hidden underground mechanisms.
Exactly, that's a crucial takeaway. The increasing frequency and intensity of extreme weather events, the steady rise in sea level, the changes in groundwater. It all means that previous approaches to coastal management are often falling short.
Like old plans.
Yeah, the paper mentions an integrated coastal zone management plan for Egypt that viewed these kinds of hydroclimatic extremes as, rare events. That viewpoint, from maybe a decade or two ago, is simply outdated now. The reality on the ground and under the ground has shifted dramatically.
This raises a really important question then. Given this incredibly complex problem driven by multiple interacting factors, what are the potential solutions? How can cities like Alexandria even begin to adapt to something like this?
It's a huge challenge. The paper reviews the main adaptation strategies that are typically discussed for coastal areas facing sea level rise and erosion.
Okay, what are they?
Broadly, you have 5 categories. There's hard protection, things to seawalls, concrete barriers, that sort of thing. Soft protection, which involves working with natural processes, like adding sand to beaches, which is called beach nourishment.
Right.
Then there's accommodation, which means adapting the buildings or the way people live in place, maybe by elevating buildings on stilts, for example. There's ecosystem-based adaptation, which uses natural ecosystems like mangrove forests or coastal wetlands to provide protection. And finally, there's managed retreat.
Managed retreat, basically moving people and infrastructure away from the most high-risk areas.
Exactly, strategically relocating development further inland or to safer ground.
So how does the paper evaluate these options specifically for a place like Alexandria? Are they all feasible?
Well, it notes that the traditional hard and soft protection solutions can be very expensive to build and maintain, and they often have their own negative environmental impacts downstream or along the coast.
Okay.
Accommodation, like raising thousands of existing buildings, is largely experimental at the scale needed for a huge, dense city like Alexandria. It's not really practical right now.
And ecosystem-based, using mangroves.
That faces challenges in the arid climate of Alexandria.
Yeah.
Mangroves need certain conditions that just aren't prevalent there, and managed retreat. While it might be the most effective long-term solution against outright submersion from sea level rise,
It sounds incredibly difficult socially and practically.
extremely. especially for Alexandria, which is geographically constrained. It's this long, narrow city squeezed between the sea and Lake Mariau inland. There isn't a lot of obvious space to retreat to without massive disruption and cost.
So if none of those standard options are perfect, what path does the study propose for Alexandria?
It suggests a hybrid adaptive approach, one that focuses strongly on landscape-based mitigation. The idea is to tailor solutions to different areas based on their specific risks and, crucially, to integrate natural and nature-based features wherever possible.
Landscape-based mitigation, like using plants and natural landforms.
Exactly. And they propose some really specific, interesting ideas.
Such as?
Well, encouraging natural coastal landscape solutions. Things like living shorelines that use strategically placed vegetation and natural materials instead of just hard concrete walls. Also integrating things like bioswales and rain gardens into the urban fabric to help manage water runoff and infiltration.
Living shorelines. How would that work in a dense city? And how does it help with the groundwater problem?
A key proposal is developing a new green street system right along the coast. Imagine streets redesigned with high tide gardens and landscapes planted with salt-tolerant species.
Salt-tolerant plants, okay.
The idea is that these strategically planted areas, especially plants with deep root systems, act like biopumps. They draw up the excess saline groundwater from near the surface and release it through transpiration.
Ah, so the plants are actively helping to lower the water table locally, keeping the salty water away from building foundations. That's clever.
That's the concept, yeah. Helping to manage that rising groundwater level naturally. They also suggest connecting this coastal green infrastructure, these green streets and parks, to the inner city via existing or new waterways, creating a more integrated system for water management and groundwater control.
What other landscape ideas did they mention?
Things like using reinforced dunes, possibly using natural algal deposits that wash ashore, and mesh-filled cages called gabions for slope protection in eroding areas. Even suggesting investigating the use of special treated wooden pillars for structural support for buildings in very low-lying, unstable ground.
And they even proposed adding new coastal parks, didn't they?
Yes, adding about 10 kilometers of new coastal parks in specific districts like Wasat and Shark. These wouldn't just be for recreation. They'd be designed as large landscape features to help stabilize the ground and provide a buffer against seawater intrusion over a wider area.
So using green space as infrastructure.
Precisely. And integrating these green and blue spaces, parks, waterways into managed retreat strategies where retreat is considered necessary or feasible, perhaps in districts like Alhambra further west or potentially parts of Shark and Wasat. Maybe even exploring new building typologies for those areas, like structures on raised platforms or even partially submerged, flood-adapted designs.
It sounds like a really integrated approach, trying to mix engineering with working with nature. But implementing anything like this in a complex, densely populated ancient city,
Right.
that must be incredibly difficult, right?
Absolutely. And the paper is very clear about this. It highlights it as a crucial challenge. A core requirement for any of these adaptive strategies to succeed is the active and coordinated involvement of all the stakeholders, meaning the different levels of municipal government, private landowners, businesses, ordinary citizens living there, the national government. Everyone needs to be on the same page, understanding the risks, agreeing on the solutions, and working together to implement them. And the paper notes that achieving that level of coordination is currently a significant hurdle.
I can imagine. Now, the study sounds very thorough, but did it acknowledge any limitations in its own research?
Yes, they were upfront about data gaps. For instance, having really detailed urban databases tracking the condition and structure of every single building wasn't feasible. Comprehensive monitoring of land sinking, like using INSAR satellite data across the whole city consistently, wasn't fully available. And extensive data from groundwater monitoring wells, particularly tracking salinity changes over time, was also limited.
So gaps in the fine-grained data.
Right, which limited some aspects of their modeling and analysis. They also noted the need for even more precise, verified data on the building collapses themselves, exact dates, causes confirmed by engineering reports, etc.
So based on their findings and these limitations, what's needed next? What's the path forward for research and action?
The paper emphasizes the urgent need to improve data collection and monitoring networks. We need better resolution data on local sea level rise impacts, on storm frequency and intensity, on erosion rates, and crucially, on groundwater levels and salinity.
Better eyes on the problem.
Exactly. And developing more sophisticated urban structural models. Models that can take this improved environmental data and actually forecast specific risks to buildings and infrastructure under different future climate scenarios. With a particular focus, they suggest, on short and midterm projections to guide immediate adaptation action.
Because the problem is happening now.
Right. And I imagine getting the community involved is absolutely key, too. You mentioned the stakeholder challenge. Absolutely crucial. The paper reiterates the critical importance of engaging local populations in developing and implementing these adaptive strategies. People living in these areas need to understand the risks they face. They need to have a voice in the solutions being proposed, and they need to be part of making them happen. It can't just be a top-down thing.
That makes sense. Ultimately, the paper argues that the lessons from Alexandria, while specific to its context, are really a wake-up call for many other coastal cities, particularly in developing nations, facing similar kinds of challenges.
Yes, they specifically note the relevance across North Africa and the Arabian Peninsula. Regions which often share not only similar hydroclimatic conditions, arid coasts, vulnerability to sea level rise, but also often similar socioeconomic contexts and patterns of rapid, sometimes informal urban development along the coast.
This deep dive into the research really lays bare such a complex, interconnected web, doesn't it? Linking global climate change, local geology, the way we build our cities, and the surprising vulnerability of the very places people call home.
It really does. Often when we see the news headlines about places like Alexandria, we see the dramatic, heartbreaking final act. A building has collapsed.
Yeah.
People are hurt, or worse. But this research, this deep dive, shows us the slow, relentless, often unseen forces working away underground.
Yeah, hidden forces.
Hidden forces, driven by changes happening at a planetary scale, quietly undermining the very foundations of the places people live. It's quite sobering.
It really makes you pause and think, doesn't it? In our increasingly urban world, with our environments changing all around us, often in ways we don't immediately see, what other slow, hidden environmental shifts might be quietly undermining the foundations of the places you live?